Scatter graphs are very similar to line graphs in that we use the horizontal and the vertical axis. However, scatter graphs have a very specific purpose. They show the relationship between two variables, or how one variable affects the other variable. And that relationship is called the correlation between the points. And you'll see that I'm going to put some correlations on the screen. And you can see what a positive correlation looks like, what a negative correlation looks like, what a strong correlation looks like, and what a weak correlation looks like. If the data points make a straight line with a high x value and a high y value, that is what creates a positive correlation. If it goes to a low y value, so it's decreasing, then it is a negative correlation. Just like a straight line graph. From left to right going up is positive. From left to right going down is negative, right? Because how do we remember that? Well, you read from left to right naturally. So if when you're looking from left to right, the dots are increasing, that's positive. If they're decreasing, that's negative. Let's look at an example. The first question says, plot the following information as a scatter graph. So we have maths mark and physics mark. So I've already put the axes in. So we have maths on our horizontal axis and we have physics on our vertical axis. So now what I'm going to do is I am going to simply plot these points. So maths is 9 and physics is 10. So I'm now going to use the 9 and 10 as an x and a y as a set of coordinates to plot that point. And that is showing the relationship between maths and physics. So I have 9 and 10. 9 on the x-axis, 10 on the y, and I put my dots. Then I have 13 and 13, so 13 maths mark, 13 physics mark, and I'm going to put my dots. And I am going to finish all the dots quickly. I'm going to plot all the points in x and a y. Alright, then what I like to do is I like to just count up my dots. Check, I have 8 dots, I have 8 pieces of information, so that I've plotted all of my dots. Alright, so this is a representation of the relationship between the maths mark and the physics mark. What I'm going to do now is I'm going to draw a line of best fit. Now, the line of best fit in lower levels, you just draw it using an estimation of what your line of best fit would be, and when you get up into higher levels, then you start calculating or determining your line of best fit before you plot it. So what we're going to do is we're just going to draw in our line of best fit, and the way that you're going to do that is you're going to try and put it in the middle of your dots. So you want an even number of dots on either side of the line that you're going to draw. Alright, and everyone's line of best fit would look a little bit different, but that's kind of a rough idea of what your line of best fit would look like. You will go all the way through the dots as well. You can see that I've put roughly 4 dots on either side of my line of best fits. And I think that drawing scatter plots are relatively easy. You just plot your points, draw your line, and you're done. Alright, looking at the next question. The scatter graph below shows information about the number of hours spent revising for a test and the test result for a group of 8 students. Alright, so we can tell that with a scatter graph question, there are 2 ways that the question can be asked. Number 1, draw the scatter graph. Number 2, interpret the scatter graph. So this is the second option. If we look at the graph, we can see that we have the test score on the vertical axis, the time spent in hours revising on the horizontal axis. Alright, the first question says, Daisy spent 7 hours revising. So she spent 7 hours revising. The question says, what is her test score? So we're going to go to the diagram, to the graph, and we're going to identify where 7 hours is. Now, if you follow 7 hours up, we'll see that 7 hours has been filled in on the graph. So 7 hours actually has a percentage of 60%. So we know that Daisy achieved 60% with her 7 hours of revising time. If we look at the next question, Harry's test score was 30%. So now we've been given the test score and asked how many hours did he spend revising. So we're going to go back to our diagram and we're going to identify his test score, which is 30%. If I look at the graph, I can see that 30% for a test score has an answer for the number of hours spent revising, which in this case is 1 hour. So Harry spent 1 hour revising for his 30% score. The next question says, draw a line of best fit. So now remember, to draw your line of best fit, it's going to be an estimate, and everyone's line of best fit might look slightly different. So what you're going to do is you're going to try to have the same number of dots or crosses on either side of the line of best fit when you draw it. Alright, my line of best fit looks something like this. The next question says, another student spent 6 hours revising for the test. So this student spent 6 hours revising. Find an estimate of their test score. Now it's saying an estimate because we're going to be using our line of best fit to determine the estimate. So what we're going to do is we're going to go to our diagram and we're going to find 6 hours of time spent revising. Then what I'm going to do is I am going to draw a line from the 6 hours revising up to the line of best fit, and I'm going to take it across to the graph to find an estimate of what percentage this child would get if they revised for 6 hours. So we would read the number off on the vertical axis, and we can see that it's between 60 and 70. We can see that it's definitely above 65. So it would be between 65 and 70, but it won't be 70 because it's not on 70. So it would kind of be between 65 and 70, which would give us an estimate of about 67%. So we would say an estimate of 67%. Now with a line of best fit, there will be an interval that you can work with. So we would accept maybe 65 to 69. So somewhere between there. So there will be a little bit of leeway for you to use your line of best fit. Explain why it might not be sensible to use the scatter graph to estimate the score for a student that spent 15 hours revising. So if we look back at our scatter plot, you can see that this scatter graph only shows us up to 9 hours, and 15 hours is a lot more than 9 hours. So that's why it wouldn't really be a reliable estimate. I also want to just quickly show you how to use the scatter graph to estimate the number of hours spent revising if you were given the percentage. And it would work the same way as what we did do when we were given the number of hours and we needed to calculate or estimate the percentage. So it would work the same way, except you'd just be working the other way around. So, for example, if it said estimate the number of hours spent revising if, for example, the percentage achieved was 50%. Well, then you'd look at the 50% mark. You would take it from 50% to your line of best fit. You would take your line of best fit down, and you would see that it would end up somewhere around 3.5 hours or 3.5 hours. So that just shows you that you'd be able to use your line of best fit going from the horizontal axis, tracing up to your line of best fit and across to the vertical axis to get your answer. Alternatively, the other way around, starting on the vertical axis, tracing to the line of best fit and down to the horizontal axis. I really hope that this video has helped you, and I hope that you've enjoyed it too. Remember, the more you do, the better you'll be. See you soon.